But if you look at the Chinese content of the Chinese mobile phone and the Chinese cars, it's increasing year after year. Year after year, you have more Chinese suppliers that are providing power device, microcontroller, LED, whatever, and it's increasing every year. And that means the strategy of the Chinese government is successful because they reach the objective step by step.
Welcome to Tech Vision with the Ojo-Yoshida Report. My name is Bolaji Ojo. I'm managing editor and publisher of the Ojo-Yoshida Report. With me today is my colleague, editor-in-chief, Junko Yoshida. Junko, it's good to see to have you here. Well, we have a very special guest today. John Christoph is the founder, president, and CEO of the Yol Group. The Yol Group is a consulting and research firm that focuses on the semiconductor industry and the electronics industry's technology in all. There's a reason why we asked John Christoph to be one of the few first people that we're going to interview for this Tech Vision. I'm going to let John Christoph talk to us about the Yol Group, the vision for why you started it, and when exactly. How has it changed over the years? John Christoph?
Well, I started the company 25 years ago, so it's starting to be a long time. And the focus at that time, in fact, is exactly the same to what is happening at the moment. The idea was really to understand the evolution of the semiconductor market from the point of view of the market, the technology, and the supply chain. Because semiconductor industry is really changing every 18 months with new technologies, talking about memory processors, but also power devices and so on. So you cannot understand the dynamic of the market without understanding evolution of the supply chain, technology implemented in production, front end, back end, but also substrate, and all these things are really the heart of your development activities.
Right. I think that's where Yol differentiate itself from other competitor, the market analysis market, because it's usually people are focused on technology development or market forecast. It's either or. And the fact that he's bringing in supply chains as well as manufacturing is quite unique, I think. Right?
No, yeah, clearly. And we get this feedback from our customers. We are working on all the supply chain. So system makers, automotive, mobile phone, pacemakers, so all the system makers that need to understand technology evolution, supply chain evolution. We are working for the device maker, but also their own supply chain in terms of equipment, materials, foundries, all that, whatever. And this ability to work from the basic supply chain in terms of materials, equipment, up to the system makers, I think is key to be able to forecast what is happening in this industry. From the technology point of view, from the market point of view.
What have you seen that have changed, whether since 25 years ago, or even much more recently when we've had a series of events that have made the entire economy, it doesn't matter which part of the economy you operate in, to think about electronics and semiconductors?
Well, I think there is two things that are really have changed in the last 25 years, both linked to the structure of the semiconductor industry and linked to the user of these devices. From the structure of this economy, if you look at memory and processing, which has always been the heart of this industry, it's 60% of the market, so it's a big part of it. But 40% is linked to power devices, image sensors, silicon photonic, strange things that are reusing semiconductor process to make non-logic digital devices. And this part is growing faster compared to the other activities. And it's also more stable. The memory pricing is going up and down. It seems to be restarting at the moment in terms of price. It's good for the industry. And it helps to stabilize all this semiconductor business because, well, the prices are not going up and down in this industry. So you have structural change of the industry because of that. The second point is linked to the involvement of multiple players in the semiconductor industry coming from different parts of the industry. Automotive makers are now starting to design chips. Nothing was like that in 25 years ago. It really started with Tesla. And after the COVID, with the understanding of the system makers that, well, they may lose the understanding of the supply chain, and which means that they are not able to produce cars just because they don't have the small microcontroller for the windows, and that's life. And so the evolution of the supply chain has been extremely strong in the last 3 to 4 years, with both the system makers understanding the importance to manage the supply chain up to the device and even up to the foundry, the OSAT, and so on. And on the other side, a fragmentation of the industry with multiple devices that are outside of this digital world, but which are more and more important.
I wonder though, Jean-Christophe, when you look at the fact that the structure has changed, the players have changed, and then you have so many other segments of the economy that's involved now. When you look at those, even segments of the economy that were not kind of focused on things like this, pulp mill, the wood industry, and things like that. What do you say to folks who suddenly find electronics on their doorsteps? They have to change the fundamentals of how they operate. How do you relate with them?
Yeah, well, it's fun because just an example, we have been working with Thames Water, so the organization that is managing the water in London,
Okay.
because they are looking at the evolution of UV LED for the sterilization of the water in terms of changing from UV lamp to UV LED. And this is exactly what's happening in this change of this semiconductor industry. You have users that are looking at device evolution because it changed completely the cost structure, the way they organize the production. Here it's the production of water you can drink. And so we have interaction with that kind of companies because their concern is, I think, at 2 levels. How the evolution of these devices is impacting my business.
Okay.
First point, in terms of specification,
Right.
cost, time of replacing UV lamp compared to UV LED, that kind of things. And the second is how can I get access to the most innovative devices? Because I'm relying on a system supplier that are my tier 1 supplier, who is relying on a supplier of device or module, who is relying on a device maker. How can I get access to the innovation up to the device maker in order to be able to get the innovation that is good for me without having the issue of waiting for the system maker to integrate the innovation of the module maker, which is waiting for the integration at the device level.
So 2023 has been, it was kind of like a consequential year with so many changes. So let's step back and look at what did you see in 2023 that you believe will inform and help structure what happens and how companies respond in future?
For me, there is really 4 things that are extremely important for 23. One is incredible investment and forecast of investment of manufacturing capabilities. 300 millimeter, but also 200 millimeter.
Right.
You never had so many companies that are investing in production. So it's really incredible. So some of them have been postponed because market is not moving that fast. But the level of investment for the next 5 years is just incredible. First point. The second point is that, mobile phone is going down and going down and going down, and there is a bottom on that. Will it happen this year, next year? But we are closer and closer to the bottom of this decrease of the mobile phone market. And at what point it will restart? Because everybody needs to, at one point, to get a new one. It's not every year, maybe it's every 2 years or 3 years, but we are getting closer to that. So this decrease of the mobile phone business has really impacted the market, the overall market, and has transferred some of the manufacturing to automotive, okay? Which has been a key market, at least at the beginning of the year. There is a soft landing at the moment of this business because, the EV is not selling as much as everybody was thinking. There is a delay also in the new cars that will hit the market. So this is, I think, the third part that is important is that automotive is becoming a big part of the industry, but it cannot replace mobile phone industry. It's just another big part of this industry. And the last part has been, in fact, a very strong decrease of the business, around 15-20%, which is mainly linked to the decrease of the price of the memory activity, not decrease of the overall units.
Yeah.
Overall units is increasing, and it's continued to increase. So the market has decreased because of memory, because of decrease of the price.
Yeah.
But some of the prices have increased by 30% compared to 2019. So it's more, for me, this 20% decrease of the semiconductor business 23 that we are expecting is more a back to normal situation.
I see.
Where, well, price increase during the COVID has been extremely high. Most of the companies have tried to get more from their customers that were starving from devices, and well, now things are going back to normal. One of the key uncertainty also at the moment is the level of stock of the how the companies are managing the inventory. Because it was such a problem during the COVID. All the companies get a lot of inventory at all level of the supply chain, at a distributor level, at well, module maker, at system makers, because you had to manage something. We have a customer that is making, which is an EMS. Some of the customers...
Which is what?
An EMS.
EMS.
An
Okay.
EMS.
Yeah.
One of the customers in the medical business asked them to have 3 years of inventory. 3 years of inventory to be sure that they are able to produce during 3 years, because they had suffered so much during the COVID situation that you had to do that. There is a big uncertainty linked to this inventory evaluation at the moment. A lot of analysts saying, okay, it needs to go down again because it's too high. And we have a lot of system makers that are saying, no, we need it in order to have the belt and the suspenders for the next years, because
Just
you know what
in
will
case.
happen. Just in case.
Instead
Exactly.
of just in case. Right.
And exactly. And this is a big uncertainty for the future, because at one point inventory level is very high, but it's also because there is a willingness of the system makers to avoid mistakes that happened during the COVID period.
Who is going to pay for that, Jean-Christophe?
Big question. Nobody wants, like always, and it's a big question. So my feeling at the moment, there is really a battle on at the EMS level, so the one that are manufacturing the cards, the systems, the system makers and the device makers, to understand who will pay for that. And it's part of the big discussion for the future. And there is no single answer. Automotive has different answer compared to mobile phone, compared to the other part of the industry.
Yeah.
And the memory of what happens at the beginning of COVID is very strong, because the automotive maker decided Q1 20 to stop production of cars because it was COVID.
Right.
Nobody was understanding exactly where the industry was going, and some of them pushed back the inventory to the device maker, saying, okay, please take that back, we don't need it. And so there is tension in the relationship between system makers and device makers, especially in the automotive business at the moment, saying, okay, who is paying for that?
Yeah.
And it seems that it's more the system makers that are doing that at the moment. But the relationship and the power in the relationship will change step by step, of course.
You know, I have a question, especially we have seen 2023, the direct relationship between automotive companies and foundries. I have never seen that before, right? Because the automotive companies up until recently didn't even really care which chips are inside the box, which car companies asked the tier ones, bring me that box to give me that function. That's what they used to say, right? So how do you make out of this new relationship starting to unfold between car OEMs and foundries?
Yes. Well, two things. Well, a long time ago, Ford had the microelectronic manufacturing capabilities. Ford Microelectronics was in Kokomo, and it became Delphi. So, Daimler-Benz, in the same way, had manufacturing activities. It was Stemic in the old days. So, automotive maker had manufacturing of semiconductor 20 years ago. Because Stemic, for example, moved out of Daimler, I think it was 20 years ago, something like that. So,
I've forgotten about that. Yeah.
No, so we are back in days where, well, it's important. And so they need to secure access to the manufacturing capabilities, and they don't want to buy the fab. Does it make sense? Right. So they are co-investing in fab, they are securing supply chain for multiple years, and this is what is happening at the moment for the key devices. Right. And, well, it's already what is the case in the mobile phone industry. Okay, it's the case. Apple is securing multiple TSMC manufacturing and so on. Right. Same is doing with other players in the mobile phone industry. And it was the case in automotive 20-25 years ago. So I think we are more back on
normal
things where you have key suppliers and you need to secure the access to the key suppliers.
I see.
They have just forgotten that it was key to get access to microcontroller, to
Interesting.
memories, to that kind of things.
Right.
One thing that surprises me about this kind of shift is that you have companies come back to what they used to do. But it's like a situation where you're under pressure and you decide, no, we need to get these supplies. Well, what happens when you're no longer under pressure?
Well, I think there is one point that especially the automotive maker have understood in the last year is that working directly with device makers help them to do two things: secure the supply chain, get access to innovation faster.
Right.
This is exactly what Tesla has done with the integration of the silicon carbide in the inverter,
Right.
or for the chip they are designing for the autopilot.
Right.
And securing the supply chain may disappear because we will go back to normal, and maybe you have to allocate resources to do that, and maybe this allocation of resources could go to other things. But access to innovation will stay. And I think this interest on innovation, differentiation linked to device innovation,
Right.
is really here to stay for the next years. And it's a key shift of the industry, and it's something that is structural in the industry.
You know, I like that. I want to take you one step further, though. You said, the connection with innovation will change, but you are looking at it from the product or technology side. But they also made changes also in how they manage their supply chain. And by just kind of extending your logic, isn't it possible that will also stay?
Yes, I think the change in the supply chain and the management of the supply chain will really stay. There is so many investment in front of the car makers linked to electrification, access to batteries, access to battery management systems that are innovative, how to recycle the batteries, because everybody is talking about the gigafactories. Nobody's talking about the giga trash.
Yeah.
Because in the next 10 years you will have thousands giga trash to manage the batteries.
Yeah.
And this is a lot of money to invest here. So at one point you may have different allocation of investment.
Yeah.
And if the supply chain semiconductor is okay, maybe you will not see what we have seen in the last months and in the last years. But access to innovation is still key because of the pressure of competition at the car level, because there is a huge push linked to electric cars from China, because there is a big push from the European car makers in order to be able to be in front of the Chinese, in front of Tesla, and having innovative cars on top of that.
Right.
And you need to secure access to innovation deep in your supply chain, deep in the battery industry, but deep also in the semiconductor industry.
Yeah. Okay.
And this will last, I think.
Yeah.
If you look back at 2023, what's your review on assessment of the role that governments have played? I mean, we have the CHIPS Act all over the place, but it's gone beyond that. So when you look back at 2023 and maybe even beyond that, what role has governments played?
Well, I think here also you have to differentiate Europe to US to what's happening in China and in Asia.
Okay.
My understanding of the European play and the European Chip Act is to say, okay, we need more manufacturing activities in Europe to support the European industry, which is automotive, industrial, medical, but it's not mobile phone, it's not servers, it's not computing.
Right.
And so there is, I think, important thing that is happening at the moment is the push toward the Infineon, the ST, the NXP of the world, or coming companies like TSMC in Europe, but focusing on that market.
Right.
One thing is difficult to understand for me is why Europe is supporting Intel in Europe.
Yeah.
There is no interest for the European industry.
Yeah.
Having processors manufactured in a fab in Europe that costs $10 billion to the European structure, that is a copycat of what is happening in US. In US, there is no interest for the European industry, but okay, just a sidewalk. But European is really focusing on supporting its automotive industrial industry by having access to manufacturing. Okay? And this is, I think, very important. And well, it happens already since a very long time. There is European projects that have been in place since almost 30 years in order to support the next investment of ST, the next investment on Infineon, and it was really allocated on the big players. What is new is that now it's going down in the supply chain and attracting more companies, smaller companies, and companies that are coming from abroad. And this part is new for Europe. But supporting the key leaders, ASML, ASM International, Infineon, ST, and so on, had always been in place by the European funding mechanism that has been already extremely strong.
Yeah.
Now it's at a higher level, but it's just an amplification of what was already the case in the past. I think what is really new is the US CHIP Act. US CHIP Act is really brand new because the US government was not supporting the manufacturing activities. It was really the job of the company.
Exactly.
And the amount of money that is put in place is really without any history behind that in US. And it's really supporting a strong investment from US companies, but also from abroad and across the whole semiconductor supply chain. It's memory, it's processing,
That's true.
it's of course other type of devices, but it's really for everything.
Right.
And it's really, this part is very new for me.
Yeah.
The last part is China. China has been supporting its semiconductor industry since 20 years, since the beginning, always trying to be as self-sufficient as possible.
Right.
So, and the amount of money they are putting on the table is still super high. So they have issues because of the ban linked to equipment, devices, and so on that is coming to US.
Right.
But if you look at the Chinese content of the Chinese mobile phone and the Chinese cars, it's increasing year after year. Year after year, you have more Chinese suppliers that are providing power device, microcontroller, LED, whatever, and it's increasing. And it's increasing every year, it's increasing. And that means the strategy of the Chinese government is successful because they reach their objective step by step.
Right.
And it took them 25 years, it will maybe took them and again 25 years, but they have no financial quarter reporting at the end of the month. They have 25 years in front of them.
Long view always wins.
Exactly, exactly. And so every year it's increasing. Yes, they have problems. Yes, it's super complex. They don't have access to the last equipment from ASML, from Tokyo Electron, from Applied Materials, but they're increasing the content in each car, in each mobile phone they are producing. And it's a strategic importance for every player of this industry.
So when you look at the regional landscape, how it has shifted, that's significant, right?
Yes, it's very significant. And I think what surprised me a lot is that you have it's an industry that was not so fragmented 10, 15, 20 years ago. Intel was dominating processing. AMD was very small.
It was small.
Nobody was competing with Intel.
No.
Now Intel is competition with NVIDIA, AMD, smaller players in this AI business.
Right.
And it's a huge competition. And the growth of NVIDIA, but also the growth of AMD is really important.
Right.
And Intel is decreasing. So you have more competition in an industry that was 20 years ago, more one player that was dominating everything.
Right.
You look at power devices. The same, you have 3-4 companies that are in the same size. There is only 3-4 companies that are in the same size in terms of sales activities. It's Infineon, it's onsemi, it's ST, it's Renesas. But they are really competing. And it's US, it's European, it's Japanese companies. And so you have an increase of the competition in all the different parts of the industry. Only one place, well, 2 places where the level of competition has really decreased is lithography. ASML is dominating the world. Nobody is able to compete against them.
That's
and foundry. TSMC is dominating the foundry business. It's incredible. They are 3 times, 4 times bigger compared to the first competitor. It's huge. It's huge. And so you move in this industry from key leaders that were really dominating that business. Memory was the same. Memory was dominated by Toshiba. It was very strong. Now, okay, Samsung is very strong, but Hynix is also strong, and Micron is strong, and there is an equilibrium with 3-4 players in most of the different parts of the semiconductor industry. And it has been really a big change in the last 20 years. And there is few parts where you have only one player that is dominating. And as I said, it's lithography. For the other front-end equipment, well, Applied Materials, Tokyo Electrons, Lam Research, and a few other companies are really competing a lot. And Apply is not the only one. There is really a competition. And clearly, Foundry is the other part where TSMC is really the leader, and the extremely strong leader.
Yol has you've been recruiting analysts and researchers in China. So when you think about what's happening in that part of the world now, compared with the evolution that's taking place here, what's going on in China? What happened rather in China?
Yeah. Well, we have been involved on the Chinese market since the beginning of Yol, so it started a long time ago. Okay. What surprised me in China is two things. Until last year, the last 18 months, so before that, our Chinese customers were asking about evolution of the world semiconductor market, what's happening, how the business is growing. In the last 18 months, more and more they are focusing on what is the evolution of the Chinese market. And there is few players that are really looking at the big picture.
Sorry, before you get into those players, why? Why do they change their...
Because there is increased content of Chinese device in cars, in mobile phone, and this growth is sufficient to absorb part of the capacity and the extra capacity they are putting in place.
Right.
And you have a lot of, let's take the example of power device makers. You have a lot of power device makers from China that are at the moment just focusing on electric vehicles.
Yeah.
Okay.
And then they will expand outside China. But first is to push the Infineon, the ST, the onsemi of the world outside of the Chinese electric cars, take the seat, and then see what they can do next. And it's the same in sensor, it's the same in, they try to do the same in the memory business, DRAM and NAND. It has been blocked because of the access of the equipment. But there are really multiple players in China. Their focus is really to focus on Chinese business first, and then to expand outside of the world. Because there is lack of issues, of course, to focus on the Chinese market at the moment.
Domestic market,
and the market is big enough just to replace the non-Chinese suppliers. So we have seen a very significant shift on that. So it's not all the players. There is always Chinese companies that are willing to be the leader, SMIC in terms of foundries, for example, but also device makers. So first shift has been very important.
Okay.
The second change we have seen is that, well, because of this continuous investment of the government and the funds that are the investment funds that are related to government, money is going again and again and again to the Chinese companies, and they are supporting development of the next equipment, the next device, and supporting the next capabilities in terms of production. Take BYD. I think BYD, they have 5 fab in China scheduled for power device manufacturing. 5 fab. They have announced that this summer. It's huge. Will they do all of them? We'll see. But they have announced that there is a continuous investment of BYD Semiconductor to support their need and the need of the other car makers in China. Huge investment. And this is for their own business. It's just for the Chinese market.
So this BYD Semiconductors, their focus is power devices? Or
yes, power device and microcontroller.
Microcontroller,
they have announced to move into the microcontroller business.
I see.
In order to be involved also on that part.
Wow.
And it's a big challenge. It's a big challenge also because in this microcontroller business, they are afraid to use ARM architecture because, well, will they get access to that? So they move to RISC-V.
Right.
And so they are building their own structure in order to be able to use their own device in their cars, pushing ST, NXP, Infineon out of that business and Renesas out of that business and grow the market.
Right.
And they have clearly announced what they want to do. They want to have Chinese microcontroller based on RISC-V in their cars. Point.
Is that the same idea that when China is so big on the chiplets, for example, the automotive market?
Yes, yes, exactly. So a way for them to overcome the fact that they don't have access to leading-edge technologies, and using chiplets is a way to build it in a different way and build power in terms of processing power in a different way.
Yeah.
What's your assessment of chiplets? How far will it go?
Well, I think it's you can look at chiplet in a different way. One is a validation of that integration in the semiconductor business is now coming from front-end, packaging, and substrate. Right. Because the chiplet is the use of innovative substrate, in terms of integrating, in terms of packaging, 3D integration, hybrid bonding, whatever, devices that are coming from front-end manufacturing.
Right.
So chiplets is industry validation that yes, integration is coming from three ways in the semiconductor industry. And you have to take into account packaging, you have to take into account substrates on that. The second point is that, well, the access to leading edge technology is starting to be so expensive and so difficult.
Right.
Difficult because the Nvidia, the Apple, that kind of companies of the world are really preempting the production capabilities at TSMC. And access to these leading edge technologies cost a lot of money. And you need to have volumes that are enough to get access to that and paying the price that is at the right level. Chiplet is a good way to overcome that in order to use technologies that are less advanced and be able to have less complex chips and be able to use just complexity when needed and not in a big device, let's say like that. And it's a way to bypass these difficulties to get access to leading edge technologies and the cost of leading edge technologies.
The point that I was going to ask is that chiplet can disaggregate SoC. That's number one, technological speaking. But chiplets can also disaggregate the industry itself.
Yes.
Right?
Yeah,
The role of the foundries, role of the OSAT. You said TSMC has been winning, and it's like it's the leading foundries, right? But maybe chiplet could change the topology of the foundry business. What do you think?
No, I agree. And it can really reinforce the smaller one, the UMC, the SMIC of the world, because they can get more business on that. And one of the, not the issue, but the possible evolution of TSMC is to be really the foundry of 5, 6, 7 companies that are just, at least for the leading edge, just using the capabilities. And it could be the foundry of Apple, Nvidia, maybe AMD, few 5, 6 other companies, and that's all. And if you look at the main customers of TSMC, it's starting to be like that. The big customers, it's billions of dollars every year. And you take the top 10 of TSMC customers, it's really a very significant part of the production. And nobody can access to that. Because you need the volumes, you need the price, you need that kind of thing, which is really complex to get access. So yes, I think chiplet can really change the structure of the industry,
the balance
between power. Nobody is able to invest and to implement leading edge technologies compared to TSMC. We'll see the impact of Rapidus in Japan, which is the objective to put a 2 nanometer fab in the next 4 years, I think, in place in Japan. It's an incredible project. How successful they'll be, well, the future will tell. But such initiative is really one of a kind. Nobody is really willing to compete against TSMC because, well, what is at stake is really complex. And so I think TSMC will not, nobody will be able to compete against TSMC in the leading edge, but the structure of the industry can really change because there is more space available for the other foundries to grow. And I think, I think it will certainly happen.
That's to me, that's the most interesting part about chiplets.
Exactly, yes.
So some of the restrictions on technology transfer that the US government and Europe has placed on the country.
It's really a question mark. Because if you look at the different constraints of the Chinese semiconductor industry at the moment, they don't have access to leading edge equipment, especially linked to lithography. So they have to do what they have, and it's complex. But the last it's a P60 of Huawei show that they are able to make chips that are advanced and more advanced than 40 nanometer. Okay, so there is tricks to implement, and they're implementing tricks in order to be able to manufacture more advanced nodes. So there is an issue linked to the equipment. And being able to manufacture chiplets with not leading edge equipment, well, maybe there is a problem. I think what we see at the moment is that they are moving to this direction of chiplet with what they have in hands, be able to use these advanced packaging technologies, the substrate, because there is a lot of advanced substrate manufacturing in China, and do with what they have. And I think they will start from that and go to the next level. It's not so advanced compared to what we see in US, clearly, but they are doing that their way. And Well, at one point, what is fun in the semiconductor industry is that you have always the leading edge development, and few companies are taking benefit of that, and you have the good enough approach.
Right.
And I think they are moving this good enough, saying, okay, it's not great, but it's good enough.
Yeah, do what they have. Yeah, do with what they have. Yeah,
exactly.
Yeah, that's how Japan actually lost the war against Korea when it comes to the semiconductor war. Japanese never gave up on this. We have to be the best, right? And so it's like good enough is a really important concept.
I totally agree.
Yeah,
yes,
yeah,
I totally agree.
yeah.
Totally agree.
Yeah.
And well, as I said, if you are looking at these leading edge technologies, it's what is 25-30% of the semiconductor business. So it's a big part of it.
Yeah.
But it's just 30%.
Yeah.
There is 70% that can be addressed by other type of technologies, what is available in China. And okay, it's not super great. It's good enough.
There is real technology innovations that can be used as an advantage in packaging. And Yol does, you guys have put out a lot of reports on packaging. Can you help us address what we've seen in the past with regard to packaging?
Yes, well, I think it's fun because we have been able to move into this packaging business a long time ago at one of the Semiconductor West. We had a customer that was making deep RE equipment. So equipment that we are making, so the deep trench, came to us saying, okay, I have customers that want to make holes in wafers, in silicon wafers. What's the use of that? It was the beginning of true silicon vias. Because they were willing to make holes in order to be able to stack wafers, in order to make connection through the wafers. And it was Sony that was developing that. So I think there is two things. One of the key ideas of packaging, the evolution of packaging, saying, okay, you have a mismatch between the device and the packaging, okay, because of the evolution of front-end manufacturing compared to the substrate.
Right.
How can you overcome that? And the big idea, and has been really TSMC that has been pushing that into volume production, is to say, okay, let's use front-end manufacturing, but for packaging services, in order to be able to make interconnection at wafer level that are thinner and so on and so on. And I think this move has been really key for the whole industry, because everybody understands from at that point, and it was 2015, 2016, that packaging needs to be integrated as soon as possible to design the chip, and packaging is a way to further integration. Okay, and this thing has really changed the packaging industry. So you have the standard packaging that is still evolving, still growing, because TO packaging is good enough for a lot of devices. But then you have all these fan out, you have all this chiplet integration, you have all these technologies that are platforms for further integration and be able to have more power dissipation, to be able to integrate memory with processing and so on, that are really key, because it provides a different path toward integration compared to front-end manufacturing. And it's really a structural change of the industry.
So, Jean-Christophe, you've not talked about sustainability. It's a big issue. So what's been happening with regard to that area for the industry, and how big a deal is it?
Well, I think it's a very important issue to address, because the semiconductor manufacturing is not a clean process, clearly. You are using a lot of water, you are using a lot of electricity, you are using a lot of chemical materials. So you have to do something out of that. Because there is a cost behind that, I think a lot of companies have already worked on that in order to decrease the water consumption in fab, in order to optimize the electricity consumption, and so on. But what is I think different at the moment is that the device makers and the different manufacturing activities need to show a carbon footprint. Okay, what does it cost? Okay, in terms of carbon footprint. And it's really new, and this is driving, I think, it will drive a lot of changes, because saying that, just an example, saying that an electric vehicle is greener compared to an ICE car, it's a big question. I think it's a political decision. It's not a scientific decision.
Okay, so let's look at it from Yol's point of view. You said it can be a political decision, right? Is it really greener?
Yeah, from my point of view, clearly I don't know. You know, it's like nuclear energy in France.
Right.
Nuclear was not good in the last 10 years, and then it became greener.
It has to be there, right?
It has to be there
Yeah,
because you need it.
Yeah.
And so, well, now everybody's saying, well, with the nuclear energy, you're not manufacturing CO2. There is no CO2 emission.
Yeah.
It's great. Well, there is other things that are really bad, but it's a matter of looking at the different things.
It comes down to something in the supply chain that's always calculated: the total cost of ownership.
Exactly. And these things need to be handled by the device maker. They need to understand their CO2 footprint, their carbon footprint, in order to step by step decrease it. But I think saying that the semiconductor industry is green is not true. It's an industry that is consuming a lot of energy, consuming a lot of water, a lot of chemicals. But having a path to make it greener step by step, because you have to save water, because you have to optimize the recycling of chemicals, is really key for the complete industry. And I think it's important to move toward that cycle. It's happening step by step, but it will take 10 years, 20 years. It's a long process because nobody will change the manufacturing process to be greener. Nobody will change something that is working as a leading edge manufacturing in order to optimize the cost of something. It will happen step by step, and generation of production after generation of generation. And it's important, but time is needed.
So, John Christo, when you look back at 2023, who were your favorite companies that really stood out for whatever reasons?
Well, one is obvious, is NVIDIA.
Yeah.
The
What's not to like?
the financial model of NVIDIA is incredible. They have, well, it's 18 billion, last quarter is 18 billion sales, and 10 billion of profit. Come on, it's printing cash.
If the gross profit margin is 74%,
Yeah.
who does that?
Who does that? Nobody does that.
And a company that also says they're both hardware, but they're also massively software.
Exactly. And the model is really incredible. So, well, future will tell how sustainable it is, but it's not the point. The point is that, wow, it's really incredible.
Yeah.
So this is it's really one of a kind of a company at the moment, and it's linked to the explosion of AI, it's linked to a lot of different things. But the ability to sell hardware and software, I think, is unique in this industry. And it's really something that I think a lot can learn out of that. The second point is the ability of the US companies, especially the equipment makers, but also the device makers, to still grow, even if the Chinese market has been closed for some of them.
Correct.
ASML is growing,
Right.
even if the Chinese market is closed for the leading edge equipment. Same for Tokyo Electron, same for Applied Materials, same for NVIDIA.
Right.
NVIDIA lost a lot of business in China, but they are still growing extremely rapidly, and so on and so on. So the resilience of these companies, for me, is really incredible.
I see.
Because, well, China is a huge business. It was a huge business of all these companies, and they have still been able to grow, make profit, even if 20%, 25%, 30% of the business has been closed. And it's really impressive. These companies.
That's a good way to put it. It's like if nobody closed the companies because they had no access to
the Chinese market. Exactly.
Right,
And I think this is the second part that is really important. So, and it's working both ways. It's impressive because of these companies that are able to keep going.
Right.
It's impressive also in China because Huawei did not stop.
No.
In terms of manufacturing, and they are back to the number pre-Trump in terms of revenue, and we have not seen any Chinese companies close because of that. So there is a resilience of both sides, and it's something that is really impressive in 23, saying that okay, there is a lot of constraint in the semiconductor business, but everybody is finding its way to grow, to make profit, provide to the customers what they need, and the Chinese market is not that much impacted. It's impacted, but okay, nobody closed because of that. Same for US.
Yeah.
And everybody finds an equilibrium in the constraints that you are involved in. And I think it's something that is important to learn for the future. Because if you are increasing the constraint, I don't think it will decrease the evolution of the companies. They will always find a way to grow to bypass something.
Yeah.
Well, it's fun the way, so the US government put constraint on NVIDIA saying, okay, you cannot sell to China that kind of devices. So they develop devices just below the threshold. So the threshold go down with the US constraint, and NVIDIA developed something which is
Correct.
just so there is a reliance of this industry that I think is really incredible, and it's a big learning from 23 on my side.
Yeah. All right.
This is the first half of our discussion with John Christoph. He is president and CEO of the Yol Group. We've been looking backward. In the second part of this discussion, we're going to be asking John Christoph to look ahead and tell us what he and his company sees ahead for the semiconductor and electronic industry in the near future. Thank you for joining us.